Welcome, class. I am absolutely thrilled to have you all here today. Consider me your enthusiastic professor because in today's explainer, we're going to decode the ultimate mysteries of time travel. And the best part, we're not just going to stare at complex math or abstract theories. We are going to break this down using everyday objects you probably have sitting in your house right now. So, get ready, because we're about to seriously shift your perspective on reality itself.
Let's start things off by confronting this exact, mind-bending question: can we bend time without breaking the universe? This really frames our entire discussion today around the delicate balance of theoretical physics. We are constantly pushing the boundaries of what's possible, testing the absolute limits of nature's laws, but we always have to step back and ask if the math actually holds up without causing reality to just unravel into total chaos.
Okay, let's dive right into our syllabus for today's lecture. We're covering 1. The twin paradox, 2. Space-time surfing, 3. Stirring space-time, 4. Rules of time, and finally 5. Redefining time. We're going on a structured journey from simply moving through time to the actual fabrication of time itself.
Let's open up with Section 1, the twin paradox. So this introduces a foundational concept from Einstein's special relativity. Moving through time is entirely relative to the observer's frame of reference. Time isn't just some fixed, universal ticking clock in the background. It's actually a flexible dimension that changes depending on how you move through space. Let's make this concrete with a household metaphor. Imagine you have two identical kitchen timers. These are our twins. One timer just sits perfectly still on your kitchen counter. That's our Earth twin, remaining in a stationary inertial frame. But the other timer, our space twin, is strapped to a violently shaking washing machine that's running on its heaviest spin cycle. That intense shaking, that perfectly represents the acceleration, deceleration, and the switching of reference frames required for space travel. When that washing machine finally stops, you'll find that the timer that got all shaken up has actually ticked less. See, it's the acceleration and the frame switching that causes the age discrepancy, not just the speed.
And I really want to highlight that this isn't just some chalkboard theory. Take the number 8.6. During his year-long mission on the International Space Station, astronaut Scott Kelly essentially became our timer on the washing machine. When he returned to Earth, thanks to the relativistic effects of his incredible orbital speeds and acceleration, he had essentially saved 8.6 milliseconds compared to his Earthbound twin brother Mark. Sure, it's a tiny fraction of a second, but it proves this is a measurable, physical reality.
Moving right along, let's look at Section 2, Space-time surfing and warp drives. This is where we transition from just moving through time to actually bending the fabric of space itself. Enter the Alcubierre metric. It's defined as a Lorentzian manifold that allows a warp bubble to move away at faster-than-light speed without locally breaking the speed of light. Okay, but what does that actually mean for a crew inside a ship? Well, instead of a ship accelerating through space like a conventional rocket, an Alcubierre drive shifts the space around the object. The ship itself just sits inside a flat, unmoving bubble of space-time. And because it isn't locally accelerating, the crew experiences absolutely no g-forces.
And this brilliantly illustrates how the mechanics work in 3 simple steps: contract space ahead, expand space behind, and ride the flat bubble. Think of it like a living room rug. Say you want to get to the other side of the room, but you don't actually want to walk. So you stand totally still and you use your feet to bunch the rug up tightly in front of you while simultaneously smoothing it out behind you. You are moving across the room, but relative to the exact piece of the rug you're standing on, you haven't moved an inch. You are quite literally surfing the fabric of reality.
Let's transition to Section 3, Stirring space-time with Tipler cylinders.
Now, what's really interesting here is how massive, incredible rotation could theoretically let us travel backward along a closed time-like curve. Imagine you're making your morning coffee. You pour in a thick layer of cream, take a spoon, and stir it incredibly fast. In this scenario, the spoon is a rotating Tipler cylinder. As it spins, it drags the fluid, which is space-time itself, around it, creating a vortex. If the cylinder is incredibly dense and spins fast enough, it twists space-time so severely that the flow of time actually tilts backwards. This would theoretically allow a ship following that swirl to arrive before it even departed.
But let me ask the class a quick Socratic question. What's the catch? Why can't we just build one of these in our backyard? Well, as Stephen Hawking famously stated, I can prove that to build a finite time machine, you need negative energy. Hawking proposed the chronology protection conjecture. This basically says the universe fundamentally prevents these closed time-like curves.
To make a finite Tipler cylinder work without it just collapsing into a black hole, you need exotic matter with negative mass. It's almost as if the laws of physics actively protect the timeline from being messed with.
And that segues perfectly into Section 4, Rules of Time and Preventing Paradoxes.
So class, what happens if a causal loop threatens the timeline? We all know the famous grandfather paradox, right? You go back, stop your grandparents from meeting, so you're never born, which means you can't go back, so they do meet. It's a total universe-breaking loop. Well, enter the Novikov self-consistency principle. This acts as the universe's ultimate defense mechanism. It states that time travel paradoxes are inherently impossible. The probability of an event changing the past is exactly zero. The timeline is self-adjusting and globally consistent. Think of this principle like the autocorrect feature on your smartphone. You try to type out a massive universe-breaking paradox, but the universe's physics acts like an aggressive autocorrect, forcing the outcome to spell something logically consistent. A gun jams, you slip on a banana peel, the universe literally autocorrects the paradox away to preserve history.
We can actually see this mathematically by contrasting unitarity with linearity. Unitarity dictates that total probability always equals exactly 1, which preserves the absolute predictability of quantum events. Linearity, on the other hand, preserves quantum superpositions. What this means is that these fundamental quantum mechanical rules shows self-consistency isn't just some fun philosophical idea. It mathematically ensures that events unfold without breaking predictability. The math simply doesn't even allow for a paradox to exist in the first place.
Which brings us to our final section, 5, Redefining Time Through Entropy. Class, we are now stepping onto the absolute cutting edge of modern physics.
So, the crucial point here revolves around a framework called VERSEF, or Void Energy Regulated Spacetime Fields. This is a framework where temporal structure emerges from entropy gradients during quantum measurement. Let me simplify that a bit. This means time is not a fundamental dimension. It isn't just a ticking clock in the background of the cosmos. Instead, time is an emergent clock field driven by changes in information.
So wait, does time really just emerge from spilled milk? Let's break down VSF with exactly that metaphor. Imagine a cracked egg, or a spilled glass of milk. You drop a glass, it shatters, and milk splatters everywhere. That messy, irreversible transition from order to chaos, which physicists call an entropy gradient, is exactly what acts as the engine generating the flow of time. Under this framework, time is quite literally the exhaust fumes of things happening and information scattering across the universe.
And this leads us to a truly profound realization. To quote the source material directly, causation does not sit within time. Causation creates time. In moments of change, time is born. This absolutely cements the idea that our universe is not just some frozen block of predestined events. It is a living, breathing process created by action. Every single interaction, every quantum measurement, actively generates the time we feel.
Which leaves us with this final, truly provocative thought to conclude our explainer. Are your choices and localized entropy actively generating the time you experience right now? Are you literally the engine of your own timeline? I want to thank the whole class for attending today. I really hope this leaves you pondering your own localized impact on the magnificent, highly responsive fabric of reality. Keep questioning and keep exploring.